Okay, this is the panel on evolution of databases at Facebook, of distributed databases at Facebook. A quick intro, I'll be the moderator of this panel, so if you guys have questions, be nice to me and ask me, I'll ask them. But let's keep it interactive. We'll do a few rounds of questions and then we'll open it up. I'm one of the founders and the CTO of Yugabyte, and I was also at Facebook, so this is almost like a family reunion for most of us, hence we couldn't stop talking and get on the stage, so it's fun, but it's going to be a lot of fun. A lot of interesting stories all the way from the early days. Folks are seated in an interesting order, right from in the order at which they joined Facebook, and it's also going to give an idea of what kind of problems they faced and noticed, and et cetera, et cetera. So without much further ado, I'll let the folks introduce themselves, like maybe to kick it off, like Jeff.
How do you do? I'm Jeff Rothschild. And
Is it switched on?
let's see.
Sorry, yeah.
Okay. I'm now a mic'd Jeff Rothschild. Great to be here. Any good talk on evolution should start with the dinosaurs, so I think that's why they put me first. I joined Facebook in early 2005. We were a college website, and if you think about how you would build a database and a site for your school, and you weren't necessarily thinking about all schools, that's about what Facebook was. So there was a simple MySQL database that encompassed all of the data and relationships that would exist at the school, such as friends, users, pokes, messages, events, classes that people were attending. And when Facebook spread beyond the first university at Harvard, well, you had to create another table, foreign friends. These were people who actually you knew who weren't at your school, maybe friends from high school. When I joined, we had just about 2,000 schools signed up for Facebook. The database, though, was really 2,000 copies of what had initially been built at Harvard. And the user ID of every user defined their database. We actually took a slice of bits out of the user ID and it said you were in this database, which implies that the database you're in carries semantic significance, which opened up an amazing can of worms. So here was my life in early 2005. Someone actually graduates, because the site was started in 2004, so we had people leaving school in 2005, and some go to graduate school, so they write you a letter. I graduated from University N, and now I'm going to law school at this school. Can you move me to that school? Well, as I mentioned, the ID for a user existed to find their database, and that carried a lot of significance, such as everybody in the friends table had to be at that school. So we had a transfer script, and won't go too deep in the weeds, but you could imagine that it had to find every instance where that user was referenced in all 2,000 databases and change their user ID to a new user ID pointing to a new user record in a new database, and take all their friends that existed at their old school and add them to the foreign friends table in the new school. And this was an expensive, lengthy process, and we wished that people didn't graduate. They stated if they were held back another year, it would have been operationally a lot easier. But all kidding aside, we did not have a distributed database. We would have loved one. Our dream would have been to have resource pooling, where the database or the container that a user's data existed in was not semantically significant. University of Texas was a really large school. Oberlin College was a small one. But we had a hard time fitting one University of Texas on a single server. So we typically had about 20 schools per physical database server. We load balanced by moving a school, which we typically would do at 3 in the morning, because we said if there were under total 3,000 users on Facebook, we could just shut it down and move databases around. Nobody would care. They should have been sleeping anyway. They are students. But we would have loved to have had a distributed database. We didn't. And a lot of the evolution of SQL at Facebook over the next 10 years was building infrastructure around MySQL to allow us to have coherence between local cache and remote databases, so cache invalidation on a distributed scale. So we rewrote multiple times the cache invalidation and consistency mechanisms, and of course, probably our biggest change that occurred in early 2006, we broke the relationship between a user and the database and having any significance. So we created a networks table, and we simply said this user randomly goes into an arbitrary database, and we'll have another table that says what groups they belong to. So you could be both a member of your undergraduate and your graduate school. And if you transferred, you didn't lose those relationships with people that you had in your first bucket. I'd say the second major shift that occurred about the same time was instead of having a schema that explicitly referenced all of the relationships that were expressed on the site and in the code base, we introduced a generalized object and association model with an association type table. And this allowed us to introduce new features without forcing 2,000 schema changes. And this, of course, was a demand almost every single day, and they weren't necessarily backward compatible. So our lives started to improve a little bit in 2006. But then we got serious, and I'm going to pass the baton on here to Dhruba to discuss how we actually started to evolve distributed SQL at Facebook.
Hi, my name is Dhruba.
Before Jeff here oversaw pretty much all of infrastructure at much larger scale. I just wanted to mention that,
I'll mention it. My role at Facebook, I was the VP of engineering. During the day, I was out recruiting people for our team and dealing with the evolution of all of our services. But at 10 o'clock at night, I put on the database administration hat, and from 10 to 1 every night, I was chasing out inconsistencies in the DBs. We were using MyISAM, and for any of you who have used MyISAM, you know that it was very easy to introduce corruption. So I was our database administration team for about 3 hours every night.
Cool, thank you, Jeff. So my name is Dhruba. I am the CTO at Rockset now, but earlier I was at Facebook for a long time. I worked with Kannan and Karthik for a long time there. Started off with some applications like Facebook Messenger, maybe working on HBase, and then later on I worked on RocksDB, and that became much more distributed by being plugged into many other distributed systems at Facebook. Before Facebook, I also worked at Yahoo, where I was building a lot of Hadoop file system, and I still remember the first time, my first project at Facebook was more related to Hadoop and migrating data from Oracle to Hadoop systems and making jobs shorter. So that was a fun time. I think I'll probably share more things later. First, let me get into it.
That's fine.
Cool. So I'm Harrison. So I joined Facebook 2010. So originally I worked on the MySQL team, helped Jeff get more sane on the MySQL side, and eventually it kind of evolved into management, and now I'm actually supporting most of our data systems at Facebook on the production engineering side. So that's caches, databases, as well as kind of the large file storage and so on and so forth. So that's just briefly about me.
Hi, I'm Vishal. I joined Facebook in 2011. So I started working on what we call core systems, which is like the fundamental building blocks of distributed systems at Facebook. So I worked on our distributed coordination service discovery, and towards the end we started the ZippyDB project that you'll hear about later. At the moment, so after that I was leading the messenger and worked on building distributed push notification service for Facebook. Right now, I'm at Facebook AI Research Lab, working on speech recognition, sort of totally different stuff, but had a fun journey at Facebook.
Yeah, that's the other hot topic, AI, for another conference. But here, I think we'll stick to data infrastructure. So, anyways,
Okay.
go on, yeah.
My name is Victoria, and I'm the youngest one here. I joined Facebook in 2015. I started with HBase, which is an open source, and I'm sure you guys are familiar with. And later on, I started supporting ZPDB that Vishal mentioned. And I'm also was a part of the journey where we moved everything from HBase into ZP, effectively. I don't want to say killing, but effectively making ZPDB the key value storage for Facebook. What else? That's pretty much it about me.
All right, we'll do a second round, guys. So maybe you guys could talk quickly about like when you joined, right? Like you could talk about like how some details, like how many people were there in the company, like how many users on the site, a couple of those type of details, and what the state of the infrastructure was. Like any details, like how many data centers, like maybe as you go down the line, it might be harder to answer, but at least for Jeff, it should be much easier anyway. So
I already gave you a lot of context on, sort of what the database challenge we were facing at the time. I joined, we had 2 million users. We had one data center. We had 100 database servers with 20 databases per server. So this was not a large-scale problem in terms of physical management. The challenges were obviously just evolving the database architecture to be something that could grow. I'd say one interesting thing to keep in mind, and as everyone on this panel took the reins of moving this technology forward, one of the metrics that we measured ourselves by was how much RAM we needed on our servers relative to the amount of data we were managing. And in 2005, we had about 8 gigabytes of RAM per server. The next set we bought were 16 gig servers, and we had about 8 gigabytes of data per server. So it was 1 for 1. And we had about 8 gigabytes of data in memcache for every database server. So really it was disk, RAM on the DB server, and memcache all about equal size in order to make this work, which we did not consider to be a good thing. And it sort of served as a benchmark moving forward to what degree we were able to overcommit the memory on the system.
yeah.
I actually have a question for Jeff. So we used to use a lot of Tau, right? That's a cache consistency system that was built on top of the database. So why was that API, the Tau API, very different from other APIs like Redis or other things which have also the concept of the list and the key?
Well, Tau was developed to support the object and association framework that had evolved at Facebook. So it wasn't so much a list API, but it was simply an implementation of objects and associations. So we had association types. So instead of when somebody wanted to add a feature, let's say a new relationship between users, we now had to create a new table. We were able to simply define a new association, let's say between two objects that already existed, or potentially adding a new object type. This lived for quite a while in the memcache framework, so where we were storing these objects in memcache. Lots of problems with thundering herds and issues of where inconsistencies were introduced. The Tau project, which was created by Venkat Maharani, who is Dhruba's partner at Rockset, addressed those problems head on, and it said that for any one update to a given to a given record in the cache, in the Tau cache, it would occur just once at one place. If multiple processes were, and of course there's always multiple of anything, nothing occurs in a singleton form. So when there's a million applications nodes trying to access exactly the same data, that only one would actually go to the physical database and then populate the cache. And so this was the Tau project, and was a major part of the evolution of the system. And another one that should get mentioned that was really instrumental was the wormhole project, and I'm sure Harrison can say much more about that. But this was our infrastructure for managing both replication and cache consistency on a distributed basis.
Yeah, I wanted to share a tidbit story about Hadoop when I joined Facebook. That time, Facebook was still running analytics on Oracle, and there were some jobs that were taking like almost 24 hours. So it could not really produce like daily reports on time because you run out of time on the Oracle database. And I remember like there was a 23-node Hadoop cluster that we set up the first time, and that same job took around maybe 15 or 20 minutes. So people at Facebook, I think, kind of realized at a time that, oh, this is good technology that we should kind of use for more of our reporting software.
Great. What year was this, Dhruba?
This was 2008.
2008,
very early 2008.
Yeah, and like any rough, like if you know, like rough number of users on the site?
I think there's around probably between 40 to 50 million people.
Users.
So already users have started to grow a lot compared to when Jeff started.
Yeah.
In like 3 years, I think there are around 40 million people.
And about like say 300 folks in the company or so?
Yeah, there are somewhere around more like 400 people.
400 people.
Yeah, I think half of them engineers or maybe something like that.
All right.
So it was a fun time.
So, I mean, and this just gives an idea of the scale, right, to folks, because, I mean, it's pretty much the digital journey that a lot of enterprises are going through. So it starts slow, but you don't know when it hits you, right, and then it keeps shooting up. So, but yeah, go ahead, Harrison, I think, yeah.
Yeah, sure. So I joined 2010. Those stats, I think we had about 1,500, maybe 2,000 employees, a couple 100 million users at that point. So even from Dhruba's time, it's 2 or 3 times that. As I said, early on I was mostly focused on the MySQL space. As Jeff has alluded to, it was pretty chaotic. With this growth, like there was various times where since we didn't have elastic computing, we didn't have elastic storage, like we actually had countdowns like, hey, we're actually going to run out of like all disk space in 3 days. And our just-in-time and elastic was like, hey, and we have these racks arriving, right? So like you'd be calling the data center people like, why are these quicker? Just because we need to actually start storing more data on these, right? And in this process, though, like as I think back, like it was pretty chaotic. The one story I have from that time, I remember once our user operations team. So these are the people that are answering user requests, working with kind of the people at the universities and so on, comes to us and is like, hey, is there a problem with the University of Florida's database? We're like, that's weird. Like, we don't really talk to the user operations people. And sure enough, we look, the database had been shut down for 4 days. We didn't actually notice, so it was super easy. You know, we just turned it back on and it worked. But it was that sort of chaos. There was just so much growth, so much churn, change, and so on that things like that would sometimes fall beneath the seams. Nowadays, you know, if we have downtime of, you know, minutes or whatever, it's a huge deal.
It's on the news.
Yeah, it's on the news now, right? So like it's a much different thing now.
Yeah, and I also remember like an incident from the time where like I think the Twitter site, like, you know, the Twitter whale was getting famous at this time because they were also experiencing a lot of traffic, and I think we used to empathize with them, and we used to be like, that might be us next week, like let's just watch out. So it used to go, and it went on for a while, I think, you know, a couple of years or so before we got out of that situation.
I actually reached out to the folks at Twitter.
I
I reached out to the folks at Twitter, their first few major outages, and said, look, we've been through some of this. We could give you some pointers. And they thought I was being sarcastic. It's like, get you know. We'll solve this. And later on, I ran into the fellow socially, and he's like, oh, you were serious. I'm sorry.
I think so, yeah. On to Vishal, yeah.
So I joined in 2011. At that time, there were about 2,200 employees, but the engineers were about 700. And the entire infra team was about 300 or so people. So the entire team could fit into a room slightly bigger than this one. In terms of the state of our storage, things actually had improved quite a bit. Actually, let me get to the number of users. The number of users grew quite a bit. We were up to like 600 to 700 million already by that time. And thanks to folks like Harrison, the state of the databases had improved a lot, but there was a class system. So we had two tiers. One was UDB, which was user database, and the other was XDB, which if you were a service who wants to use storage, you used XDB. So for the user database, you get reasonably first-class service. The DBA team is on it, and if you're a service who needs to store something, if you're important enough, maybe the DBA team will help you, maybe. But if you're not important, you're on your own. All you would get is XDB, which is a single server database instance with replication. All right, so if you're filling it up, what are you going to do? It was your responsibility to figure out how you're going to shard that thing. You have to figure out where to store the mapping between your whatever ID and the shards. You would have to do the migration yourself. And so that was pretty painful. But if a server went down, nobody likes to tell you that your server went down. You had to figure out, oh, my service is not working, my server is down. And then you would file a task for the DBA team and hope that they notice and it goes up high enough on the queue to fill it over. And of course, there was an application lag, so now you had this interesting dilemma. Okay, if I fail over, I'll lose some data, or maybe I'll just sit tight for a little bit, and maybe my server will come back. So sometimes failover DBA would fail your database over, might take a few hours after the recovery and so forth, and then fail back. So if you were a service back then at Facebook and you were managing that, you had a pretty miserable life. And that is basically part of what led to the development of ZippyDB at Facebook, where I and Dhruba were sort of started the project as part of hackathon in a true Facebook fashion. And Alex is in the audience. He was one of the initial hackathoners, and we had a prototype in 3 days. Of course, the project sort of took a while to get it officially going. Luckily, I became a manager around that time frame. So I didn't really have to convince a lot of people to do it. I just took a part of my team and said, okay, hey guys, you go work on Zippy. And that remained as a Skunksworks project for quite a while before we actually scaled it. And Victoria went through that journey of scaling Zippy.
Yes, it's actually interesting to hear all the stories, because when I joined, it was a completely different world. I am not sure how many, I believe it was around over 1 billion users at that point. Yeah, I'm not sure how many employees, but I know, I checked in the morning, I've been at Facebook longer than 92%. So just to give you how much we've grown. That was back in a time when we just had the classic, what we call the classic office, and then none of the other building existed. So it was still it actually still feels pretty small, even though we're big.
It's always 1% done.
Yeah. So what I picked up ZippyDB, which is a very small but promising service. We didn't deal with the machines. We didn't deal with the single machines. We dealt with clusters being down. A part of what we built the service where the teams did not need to care about, how to provision the service, how many machines they need to have, how much memory. Essentially, my team, will do everything for them. And so ZippyDB became this multi-tenant distributed key value storage. And the whole point of that was that users do not have to go through all this experience or call somebody or wait for 4 days until machines are going to be up. It was my responsibility or my team's responsibility to ensure that we're up and running. Just to give you the numbers, I think when you left to the point where we are right now, we are probably grew 10x and then probably 100x in terms of number of requests we're supporting, so they're pretty big.
All right, great, awesome. All right, so let's do another interesting round. So we talked about the state of Facebook and the state of data infrastructure and what were some of the issues that were happening. It'd be great if you folks can now do one round on one of the most impactful data infrastructure projects that either you were directly or indirectly involved in at the time you had joined, like a little bit after. So for example, like for Jeff, it'd be great if you can give us an idea of how did we really make the UDB tier, the distributed MySQL tier, really scalable and highly available, right? Like that we did a lot of that work, and I think you were directly involved in that. Dhruba, why did you build RocksDB? What was the reason, and what was the story behind it? And Harrison, you can talk about Wormhole and the next stage of the UDB tier itself, and so on, right? And Vishal, the ZPDB early days, and Victoria, I think I don't even know enough to ask you because you have more purview and I'm not at Facebook anymore, but it'd be good to see your point of view on the same thing, on what were the challenges and what were some of the improvements you had to do. And for those folks still at Facebook, it would be great if you can add what you see as in the roadmap in the future, right? And whatever you can share would be great. So.
Okay, so one thing I didn't mention, because I think people just have described the size of the team when they joined, the engineering team at Facebook could have sat on this stage and still left a seat open. So it meant that you were always deciding what you were not going to do. You couldn't solve every problem, and obviously, we would have loved to have had a distributed database with resource pooling, local replication, load balancing, and not having to be directly involved in capacity management for individual containers. We knew that. It wasn't for lack of imagination. It was simply for lack of ability to do that. So our challenge was, how do we build the tools and methods and best practices for scaling a large, non-distributed SQL tier? And I mentioned some of the work that was done by Venkat when we built Tau, but it would be remiss for me not to mention two people who are colleagues of Harrison, who had an instrumental role, along with Harrison, in allowing us to be able to scale the SQL tier, and that would be Mark Callahan and Domas Metsukas. And Harrison and Domas and Mark really transformed our practice of SQL. One of the good rules of thumb that I've worked with is that any database that has not been touched by experts is probably running at 10% of its capacity. So there was a lot of low-hanging fruit. There was a lot of things we were doing that we just simply had to stop doing them, like doing range scans that did not involve covered indexes. There were fields we were returning that were not covered by the index. I mean, not doing that was a big step forward. So we got better at doing SQL. We also started to get involved in the internals of MySQL. And earlier, we simply used it the way the rest of the community did. By the time I left Facebook 10 years after joining, we were taking a leadership role in evolving the platform itself. So lots of small changes contributed to our being able to scale and live with the platform and be able to master it as opposed to it mastering us. Would we have preferred to have had that wonderful distributed database that Karthik is delivering today? Of course we would. That wasn't the option to us. We would have also loved to have had hosting services, folks where we could have simply had fungible resources we could deploy on demand, and not stayed up all night racking machines in the data centers. But that simply wasn't part of the world in 2005. So I think we've alluded to some of the biggest changes. Some of it was just doing things well. Some was replacing elements of the infrastructure, like the replication layer, that needed to be re-architected. I should have mentioned the hardware helped us as well. The transition from moving disks to flash gave us a great deal of overhead. And the lovely thing about overhead is you have an opportunity to get it wrong and nobody's going to find out about it. So when we had an I/O capacity of 1,000 I/Os or 1,500 I/Os per server, and we were using 85% of that when things were humming along, and then you introduce a schema change or an application change that should have had a schema change, the result is you knock the server over, and if this was broadly deployed, you knock the site over. After that transition to Flash, when we had 80 to 100,000 IOPS per second available to us, we could get a lot of things wrong, and the reaction was, oh, let's fix that today, as opposed to full panic mode and knowing that this was going to be a story in the Wall Street Journal the next day. So that actually made our lives a lot better as well.
Awesome.
Cool, yeah. I think that's where I kind of pick up the story about RocksDB.
Yeah.
So RocksDB, how many of you have heard about RocksDB? Okay, a lot of people have heard about it, at least. That's cool. So I think RocksDB project started just the time frame that Jeff mentioned, where a lot of our storage systems moved to Flash. And so we were evaluating LSM engines, thinking that LSM engines would be the right choice for running storage on our databases on Flash. And I spent around 9 months using HBase, which is also an LSM engine. But the good thing about Facebook at that time was that the managers or the management made it very clear to me, saying that try these things out, don't fear of failure. So I did that HBase project for around 8-9 months, trying to move all the MySQL stuff that Jeff helped build, migrate them to HBase. I spent around 9 months, and then I decided that this is an LSM engine that's really tough to scale on Flash devices, because at that time, it was mostly built for hard disks. So that's the time when the RocksDB project started. I took some code from Google, which was a LevelDB project, did a lot of improvements to make compactions work faster or move it more on the server side of things. And we found by very small micro benchmarking that, yeah, this can do a couple of things better than the InnoDB storage engine in MySQL. And the first thing we measured was actually how much storage space it needs, because the Facebook database was all bottlenecked by disk capacity or storage capacity. So that was the first benchmark we did, saying that if we store 100 bytes of data in InnoDB, would it take only 50 bytes in, say, the RocksDB database? Many other things were not up to par with InnoDB at the time, but the first benchmark, like I said, we did was all about storage. And then another thing happened at the time. There were product requirements which said that, hey, we have all the data in the UDB database, and we wanted to build a secondary index on this UDB database, which is basically like, say, in Facebook, all your data is indexed by, say, the user ID or the posts, right, or the comments that you make. But now there were applications that we're building which says that, show me all the photos taken at a particular place. So now you need an index based on the place. So building complex secondary indexing was not that easy, especially when you're using InnoDB. So that was kind of the first project where RocksDB started to get used in large scale. It was to build a secondary index on the entire user database. And RocksDB is kind of tuned and optimized to run this at large scale for secondary indexing. Anything else I can share about RocksDB? I'm trying to think.
No, I think this is good. I think another shout out to RocksDB is that we use RocksDB as an internal to build Yugabyte. I think you use it.
Yeah, Rockset also. I use RocksDB a lot,
and it's pretty popular. So thanks for the
cool. Yeah, great. Again, RocksDB is not. I might have started it, but it's a great set of people at Facebook, and I think the amount of resources that Facebook put into the project is the real thing which made the project successful.
Cool, thank you. So going back to the wormhole, Tau, and so on. So one of the first things I was involved in at Facebook too was helping to to turn MySQL essentially from being kind of a standalone database into a much more kind of distributed system, right? And so that's where a lot of the magic really does happen is on the layers kind of above MySQL. I mean, Tau itself, I think, does like 6 or 8 different SQL queries total, right? So it's not using the full expression of SQL. It's much more about the distributed nature and the distributed cache invalidations and so on, right? And so Tau itself was a relatively new system as I was joining, being built, being developed, and so on. I think one of the funniest stories about this actually is we're looking for the very first thing to use Tau for. It naturally would be used for things like friends and all these other sorts of things, but we look at this and we're like, this is really important, graph data, we don't want to really mess this up. And so one of the things we decided is there was this brand new little thing coming up that at the time was called props. It eventually became what we call likes. And we're like, this will never be a thing. It's kind of the silly, a side project. So let's launch, likes on Tau. Needless to say, likes and the like button became a pretty big thing for Facebook.
Still is.
Apparently still is, yes.
Yeah. In fact, places where I can't like, I'm like, what's the site? How do I say I like this thing? Anyway,
exactly. Yeah. And so, but Tau probably spent about 4 years scaling under the like load. So it was definitely a good learning experience, but it was a big part of that. At the same time, one of the things that Dhruba alluded to is kind of some of the secondary indexing and so on. And part of this we started realizing is like having a single source of truth, in UDB, MySQL is fine, but people want to access data. We're going to need that data in a lot of different ways, a lot of different formats, right? Again, as we're adding new features, as we're doing new things, we want to be able to access this data in new and unique ways, right? And so that's where Wormhole really became a big part of this. So this is essentially a global pub subsystem. We had talked
I think at this time also there was a lot of data centers, right? Like a lot of regions as well, right? That's the other key driver to it.
Yeah, and so I joined, there was essentially 2 data center regions. We had West Coast and East Coast, and then now we're up to a bunch. So we've added another one in Oregon and a couple in Europe and so on and so forth. And so Wormhole is really the idea of getting this data out to the places that it needs to get to. And so this is, there's a lot of different consumers of this data now internally for building secondary indexes, features, all these sorts of things that are able to be built relatively quickly without having to kind of change the core internal database. So you kind of have a stable central source of truth, and then you have these secondary systems that can kind of evolve off of those. So the other thing you asked to talk about is kind of the future of where we're looking at and so on. I think one of the biggest things, and so I work in production engineering, and as we look forward, hardware is definitely one of the biggest things that continues to evolve and influence kind of our design systems and so on. So now running on the cloud, we have total access to all the hardware and get to take advantage of that. And so as Jeff alluded to, the transition from disk to flash was a pretty big thing, right? Like we go from optimizing everything towards IOPS, how do we get more IOPS out, how do we minimize that? To a world where now we're optimizing for things like write endurance or space efficiency. And so as we look forward, there's a couple other big kind of trends that we're looking at. So things like extremely large flash devices. So industry, in a couple of years are going to have extremely large flash devices. So how do you take advantage of those when CPUs, aren't actually going as fast? So now you're getting to this imbalance in the other way that we've had kind of with disks for a while for IOPS versus space. Now you have the same thing for CPU versus flash. So things like disaggregated storage. How do we actually scale compute and storage separately? Things like that are some of the big areas we've been investing a lot in. There's also some new storage mediums, things like 3D crosspoint, stuff like that, which is somewhat interesting. So how can we actually use that? How do we scale that? What's the point of the applications that this will enable, essentially, are kind of some of the big things we're looking at.
That's great.
So the project that I think had the most impact that I was involved in was ZipDB. But there was basically many steps along the way that culminated in ZipDB. So when I started, the way we would identify that a server had gone down was, somebody would be looking at charts and notice, hey, this thing went, the QPS went down here, what's going on? Or we would have alerts, and then alert would fire, somebody wake up in the middle of the night and say, okay, what do I do? So we're going to fix that first. So we built we worked off the Zookeeper code base and built a service called Zeus, which scaled at Facebook scale to do failure detection. But once we detected the failure, when we updated, saying, okay, hey, this service is not running here, it's running here now, propagating that change to all the servers and the clients at Facebook infrastructure, that took sometimes half an hour or more, right? So there is no point being able to do failover in a few seconds if you can't tell everybody that, okay, this failover has happened. So we started working on evolution of our directory service, which internally we call it SMC. So we built SMC2, where the moment you fail something over and update that entry, within a couple of seconds, entire Facebook infrastructure knows that server has moved. Then we built a component called Shard Manager, which is similar to Google's Slicer, which that component would basically enable services to do automatic shard management. It's going to figure out how much load a particular shard is getting, automatically split it, do the movement, detect when a shard is failing, fail over the shards, and so forth. So by late 2012, these pieces were in place. And at the same time, Dhruba was working on RocksDB. And RocksDB was showing a lot of promising performance. So we're like, okay, now is the time to actually make something like this happen at Facebook. And that's where we did the hackathon, and we did a demo, and so a lot of people liked it. But we still didn't do anything after that for a few months. And the real impetus came where I was having a coffee with Jeff, and just like bouncing around, I saying, you know what, I have a gut feel that this thing is going to be important for Facebook, but not everybody's convinced. What do you think? And Jeff's response was basically that got me like really committed to sort of making it happen, and that's when we sort of kicked off the project, formed the team, and started the development in earnest. And then you can tell the rest of the story.
So yeah, ZPDB was built distributed. It's by nature distributed. So my biggest challenge was to take this small thing and make it big, right? Because we're growing and more workload needed to be supported. Besides that, as Dhruba said, Facebook is really great encouraging engineers into starting new projects, just fail fast if you know. So when I joined, there's other key value storage systems that that were at Facebook. So the challenge was which one to pick, which one to invest into, because as the service becomes big, right, there's a lot of stuff that's being invested into supporting that infrastructure, monitoring, alarming, etc. Like it's not just a database, or it's not just a key value storage service, it becomes so much more. So the amount of effort that is needed to support that is huge. So the biggest challenge was how do we take all those different pieces sort of and merge it into one big database. Having HBase there, which was optimized for disk performance, and sort of kind of make those workloads run on ZPDB, which was optimized for flash, and of course the ratio between storage and memory was completely different. So all of this was a journey of 2 years, and eventually it brought Zippy where it is right now. We kind of merged all the solutions into one, actually 3 solutions into one, and that's where ZippyDB is right now.
So what were a couple of the interesting features or incidents or use cases or anything you can share along this journey, from in scaling ZippyDB to where it was, if there's anything that comes to mind?
It's a very good question.
I'm curious. I don't know about the audience. I'm curious because I wasn't around for that part. So, but
it's anyway. One big blur to Facebook, right?
I know what you mean. Yeah.
When you start a new service and all the engineers magically shift to that new service.
That's right.
So for me, the challenge was how do I keep the engineers actually? It's a journey of 2 years, right?
Yes.
How do you keep the engineers interested? Was my biggest problem. How do you support that? How do you find excitement in that? Right, so the technical solution was there, but I think we were rushing against time in a way, just making sure that things are working. I wouldn't say that there is everything was interesting. Like, we're talking about outages. ZipDB did not have SEVs, which is an incident, up until 2 years ago. And it's not because we didn't have them, it's just because nobody opened them. So we just magically realized that, oh, great. And I remember one of the meetings, we looked at the ZipDB and somebody came to me and said, oh, ZipDB really does not have SEVs. Like, no, this is not possible. Like, we do. There are just people who are opening tasks and letting us go. And we managed to grow quite big before we just kind of realized that everything was worked on tasks. And people were pretty responsive. But yeah, I think this is it was moving very, very fast, and kind of we were reacting, but there's no, I think all these war stories, and I actually love hearing them from
It's the early stages.
The early stages, the call the cops and all the other stuff, I love hearing those. Because for us right now, it's different challenges. There's not a single thing that I can say, it's just, every day it's a challenge, I would say, which is fun.
Yeah, totally, yes, totally. So that prompts another round, I have my favorite war stories, battle scars, the shit hits the fan kind of incidents at Facebook. Like there's a couple of those that I can't stop talking about or thinking about and actually feeling happy about it now. It wasn't exactly the case back then, but anyways, so we'd like to do a round where folks share your favorite war stories or battle scars. I'm sure all of you guys have enough of those, so maybe a little less as you go down, because things seem to really have gotten very organized and really, really good and highly available and so on. So, but would like to, or we can do the reverse order, if you want, if you have any, what were the oh my god moments of that you had faced?
I think it wasn't oh my god moment. I think it was from the point of HBase actually. Because we did this, we had our version of HBase, and at my time we moved to completely open source. And as a part of this migration messenger, actually the biggest sort of customer was using HBase as a storage system. And we were doing this migration from the old Facebook version.
89 FB, yes.
Which was really, really old.
Yes.
And completely diverged from the open source into the straight open source version. And I just recently joined, so that was kind of an interesting experience to be in, because we were working on this migration and making sure things are going to work. But then we did the flip on one of the clusters, and we spent 3 days. We're actually almost eating in the office for lunch and dinner and everything else, because we couldn't understand. All of a sudden, the things became slow, and we couldn't understand why, what happened, and just all the engineers beating their heads. We're trying to restart the service. We're trying to fall back. Different things happened. We found probably 10 bugs in HBase while we're debugging. None of them actually contributed to what the problem was. But eventually we realized that we, at the time, had the security enabled, and what happened was there was a old system. Somebody who's familiar with it, Nagel's algorithm. And so that was enabled by default, which caused huge pauses in the network. And I remember the moment that we had this aha moment after 3 days of constantly restarting the service with the new version and stuff like this. I go, Jesus, I cannot believe that this thing is still existing. But for me, it was a really interesting experience, because I've never been in a war room for 3 days straight. I mean, yes, given we were sleeping, but 3 days kind of were changing. We had shifts. We were organizing ourselves around that. We're eating together. And it was interesting to see how it brought people together.
Yes.
And I say that the best team building activity is actually kind of solving the stuff together. It's a blessing as a curse. So yeah, that's been fun. But there's, as much as I maybe don't remember this particular experiences, but I think it's occasionally something like that happens, and we have all hands on deck, and it just nothing of the magnitude, I would say, where a single server failure is going to cause huge problem. It's usually, as I said, it has to be the entire site or partially some of the site. Yeah,
makes sense. Yeah, let's go down to Vishal. Yeah, I think things should start getting interesting already.
So in the early days of Zippy, and this was an incident that was handled by Sanket, who was one of the key engineers in Zippy, and he's currently at Yugabyte.
Yes, currently
Yes.
at Yugabyte, yes. Yeah.
So we had ads impressions running on Zippy. Okay. So essentially, if things go wrong, there is real money involved here. So I said, okay, you know what? It's serious data. Let's turn on backups. And as soon as we turn on the backups, we would start seeing DB corruption. We were like, what's going on? Like, you know, why are backups causing DBs to get corrupted? And after like a lot of investigation, what it turned out was that we were using HDFS for backups, and HDFS client was written in Java. So because we were using that client, we were loading the JVM into the process. Now, as all people who have worked with databases know, you never hard stop a process, because then you're going to have some stuff go wrong, right? You always do a clean shutdown of the process. But what this JVM was doing was it was catching the term signal and doing its own cleanup, and at the end, it was calling exit of the process, not passing the signal up the stack. So we were not getting a chance to, they do the clean writes and do a clean shutdown. And that's what led to the corruption. And then we were like scrambling, writing scripts, doing manually, doing the cleanups. So we had some interesting learnings from this, which was, be mindful of what code you pull into your process. And of course, I think we probably learned that lesson many times over. And then also, be prepared for things going south and have your recovery processes and scripts ready ahead before we take on a critical workload like ads impressions. Luckily, it turned out we didn't lose too much money, but we had a very interesting learning experience through this.
Cool. So yeah, lots of outages over the years. The one story I want to tell actually is a little more personal, but talking kind of about the XDBs and the lack of support thereof. Back in 2000, probably 2011, we had one database that was super, super important to Facebook. It was basically the configuration of all the A/B tests that were going on Facebook. We A/B test a lot of stuff. Super highly replicated, many, many copies, all these sorts of things. Very small data set, but super critical to be there. It was cached in memcache. There was a 30-minute timeout on the memcache key because the data didn't change a lot. It was a couple hundred updates a day or whatever. But super critical that this data be available. Otherwise, like Facebook mostly stops working. And so the way the people use this is occasionally they would want to create some new experiment and stuff, and you have to create a copy of this database. So you do it on the same hardware and so on, and you'd have a couple of these kind of there. I think we're up to like 5 or 6 at this point. And there had been a task open for a while saying, hey, please create us a new one. And so finally, I decided, okay, I'll just go do this, in 15 minutes between some meetings, things like that. And so I go in there, I run a beautiful MySQL dump, I put the output into MySQL, hit enter, and it takes a long time, which is always a bad sign. That's, if you worked on databases, whenever anything takes much longer than you expect, something bad's going on there. Turns out 2 things are happening. So MySQL dump, I happen to forget, does a drop table before it creates tables. And if you specify a specific database, it actually puts a use at the top. So even though I was redirecting it to a new one, underneath it had actually switched back to the actual production main database and gone through and dropped it all. So I realize this is happening, and you get that little panic. You're like, oh, this is not a good thing. So what's going on? So I know, okay, I have 30 minutes or less to get this database back. Depends on when the keys happen to be set in memcache. They're going to start falling out, and then Facebook is going to start dying, right? And so I don't think I've ever typed so fast in my life to basically pull this in from the backup, load it in, replay the bin logs for the day, so there's only, again, about 30 changes or whatever, get back to a fresh state, I slowly load Facebook, still working. Okay, cool. So that's the time I actually dropped one of the most important databases, restored it in probably 10 minutes. Luckily, the TTL hadn't expired. Things were good there. And so now the question actually becomes, what do I do now? So I decided, okay, I should probably tell the team that owned this feature that I accidentally dropped their database, restored it, just in case something weird happens, right? So I go into the internal Facebook group and I tell them, hey, this happened. Let me know if anything weird seems to happen. I think it should be good, but let me know. No reply. 2 weeks later, it gets 1 like. So I'm not sure what that means. But yeah. So,
dropping of these critical data and restoring it, it's not even a unique story, but yes, thanks for sharing it. But I just want to tell folks that it happened quite often. It's just that, if you
I guess at that time, Facebook did not have the sad button and all those. There was only the like button. So nobody wants to like that thing.
That's exactly why we didn't put it in also, because it's like a duck on water. You have no idea what goes on underneath. So.
I know.
Go ahead, yeah.
My war story also related to configuration, because what happened was that I think in 2011, so Facebook configuration management was through a file that gets downloaded to many of these web servers. And then somebody decided, not somebody, but people I know obviously, decided that, instead of using a flat file, let me use RocksDB. So Facebook used to have a project called Configurator. I think Vishal was part of the team. I used this RocksDB, and then I shipped some code to the RocksDB compaction process where some keys were getting deleted by error. And so now a lot of web servers started to run this code, and some configurations got really screwed up, which the PHP servers can't talk to the backend services anymore. So that caused probably like a 5 or 10% outage of Facebook users for around maybe 10, 20 minutes. Before we could kind of go back and say, hey, stop shipping all this new configurator code. But that was quite stressful that day.
Where should I start?
That's right, the earlier you get, the worse. Day one.
Okay, first really bad error, because we obviously had outages like fire in the data center. Well, you can't help that one. We only had one data center. It's going to impact you. Someone was pushing the mod PHP and didn't get it on every server. So there was one of our 100 web servers didn't have mod PHP installed. So that was the one who saw PHP as something to give to your users. Wasn't something to interpret. So we had one machine that was happily serving source code for for a whole day. And I can say this because the story is out there. I think you could even find snippets of this code. Luckily, the DB password was not in that module. But lessons, my favorite incidents are the ones where you can learn something. Probably an early one shortly after we released Platform. Someone developed a set of abstractions to make it easier for developers to work with this new world of installable applications and the Facebook platform. And someone created a really nice helper routine called Is App Owner. Because when you, as the creator of an app, went to a page that included that app, you were presented with a different set of options from everyone else in the world. Let's see, 10 million users, 10,000 apps, you can do the math. That's a lot of potential combinations of users and apps. So the actual implementation of Is App Owner did what almost every good function did at Facebook. It cached its result. So we ended up with a cache key for the cross product of our users and our apps in order to determine that this one user was the owner of the app. Not a good design. It's a great case study for why it is you need to understand your abstractions and not necessarily apply a rule like, well, I have a result, I should cache it 100% of the time. So it took the site down almost instantly. Our cache lifetime went from 30 days to about 3 minutes on introduction of Is App Owner. Other interesting lessons, well, many of them relating to the database. I would say it always came down to people understanding more about what they were using. An old adage always was that the best developer was somebody who wrote a compiler because they knew their tool intimately. So we had a number of cases where users not understanding the caching and the database architecture would introduce code changes that would very, very quickly put the site into panic mode. And I'll give one other specific incident. This one wasn't too many years ago. Someone, being very thorough, wanted to assure that the data they read from the database was correct. So they put a little validation check. Is this information consistent, internally consistent? And if not, read it again. Okay, so you know where this is going. Someone introduced, just from the SQL command line, introduced a change to this configuration data, made it internally inconsistent. Every single page on the site had eventually called this library that read this bit of data that was, of course, cached throughout the memcached here. So you were never physically hitting this database until every single page read it, said, well, that's not right, and let's read it again, and let's read it again, and let's read it again. So the whole site, the thousands, tens of thousands of web servers all trying to read the same cache entry forever in an endless loop. So great lesson, which is that, if you read something and you don't like the result, don't just assume that you can repeat this process and get a different result. This was one that you could read about in the papers. I think it was about a 5-hour outage. It was one of the worst that the site had fixed. But I used to attend to the Sev review every week, and every week had new learnings. Okay.
It's great. Yeah, awesome. So I think the last bit on, if you ask a question, get an answer, don't like it, keep asking the question. It's probably good for life also, not just systems. But I don't know how we're doing on time. I think we're probably over time. Would have loved to open it out to questions. But if folks have questions, please come talk to the panelists, talk to us offline. Thank you, everybody. Thank you, guys. Thank you, panelists. This was really great. I had a lot of fun too.